Hi all. Let's start with the next video of PCIe. Till now, what we discuss in transaction layer and its features. Now we will start with the next layer of PCIe is a data link layer. As I told in PCIe, we have a three layers, mostly transaction layer. For hardware point of view, we'll see three layers. First one will be the transaction layers. Second will be the data link layer. Third one will be the physical layer. From the transaction layer, what we seen till now, what are the different packet suites will generate based on requirements. What type of packets, whether it is memory, whether it is IO, whether it is config, whether it is some related to messages TLPs. So we'll see these types of TLPs. Now we'll go through data link layer, weights came into picture. Whatever packets is generated from the transaction layer, we need to take care, like whether it is packet going to proper or not, whether it is whatever data we are sending sequence, whether it is going sequence or not. So we need to take care these specifications. So by using data link layer, we will take care of these specific kind of specifications, whether it is data going from transmitter to receiver, whether it is correct or not. If it is not correct, how we can send again, whether it is sending data is a sequence or not. Let us take one example. Let us you are listening song. It should be sequence. Like you are listening song means it should be sequence. You have to get a information such a way that it should get as a sequentially. It should not get as a. Let us take one example as a. You have a one speaker. Let's take in the PPT one example for that. We'll understand it very clearly. Let us take you have a transmitter, you have a transmitter, you have a RC. Let us take you have a EP. This is RC, this one is a EP. Let us say RC will be the your laptop CPU. Let us assume your CPU. EP will be the, let us take as a sound box, any sound box related. Let's take any speaker you are connected through PCIe. You are connected with PCIe. So what happened? Let us you are you want to listen one song in your laptop. You have one good song. You want to listen. So what it will, you will give us the instruction, like I want to play this song. So CPU, you are giving instruction to that processor. I want to play this song. So CPU will initiate the transaction. CPU will send that information to EP. EP means sound box. Soundbox say it will send the data. So what happen? You will listen that song. So it should get as a sequentially. If you are not getting sequentially means what happen? Maybe some part of song will get as a first, some part of the song you will get as a next. So it's not a good future, right? So we'll see that whether it is going sequentially or not. So these kind of features we'll see in the data link layer. Mainly we'll see as a whether it is whatever data we are sending from the RC to EP received properly or not. Whatever data we are sending through link, that sequence is correct or not. So the all these things it will take care about data link layer. So we'll see what actually happen in data link layer in the next slide. Yeah, this is the structure of PCI. I already explained what is this. This is the structure of PCI. In that we have a hardware, we have a three layers. This is coming from the software side, this is coming from the hardware side. So hardware layers we have a transaction layer, data link layer, file layer. So what is the significant here? Data link layer. Main concept is data link layer now. So whatever the pack here, what you will get as a, from the top you will get what happen, data you will get, data you will get from the top layer. Once reaching to transaction layer, what happen? It will add as a header and ECRC. Header and ECRC. CRC what happened? By using CRC you can able to detect the errors. This is a header means it will give us a more information, like where we are sending packet. Let us you have a RC, you have a EP, you are sending data from the RC to EP with a specific address. So that address, everything, whatever, let us you are sending as a membrane. So a membrane you will mention in the header. I am sending as a membrane. I am sending as a membrane with address, so and so address. So everything it will mention from the header type. data will come in from the top layers. You will by using you have to protect this entire packet, right? So by using protection, we are using as a ECRC here. Now next, once coming from the transition level, what happen? It's let us take here. You have a data header, data ECRC. Now this packet is coming from transaction layer to data link layer through this transmitter. Here will be the transmitter will be there. It will send the packet. So once reaching data link layer, what happen? It will add as a sequence number, and protection purpose we are using LCRC, link level CRC, cyclic redundancy checks. Here we are adding sequence number from the data link layer. From that, once reach the data link layer, it will append the sequence number and LCRC. Once done, that packet is sent to file layer. File layer, what happen? It will add as a boundary, start and end. So when it will starting packet, when it's sending packet. So it will clearly mention like whenever you are sending data through this link, what happen? It should not be corrupt. It should send as a proper manner. So whenever data packet is started, it automatically receiver will understand like, I will get as a start. Next I will get as a sequence. Then I will get as a header. Then I will get as a data. Then I will get as a ECRT. Then I will get as a LCRC. Then I will get as a end. So receiver will get clear vision like, next I will get next packet I will get. So here you will get as a whole packet, but once receiving transmitter, what happen, it will split. First it will spend as every 8 bits, right? 8 to 10 bits encoded. Let's take one example as every 8 bits you are sending. So for, let us assume this start is 8 bits, so first 8 bits will send. Then this is assume also 8 bits, so the second will be send. Then after third will send, fourth will send. So every transaction it will go for only 8 bits. Let us take a header is a 411. Let us assume it will have a some, let us assume 64 bits, some will be there. So it will send first one will 8, next 8, next 8. It's so it's sequentially it will send. So it won't send entire packet in at a time. It will send as a sequentially every 8 bits. It will split. Whether you are sending packet is a variable, but you are how much maximum you can able to send. If you use any 8 to 8 to in encoding, you are using every 8 bits you are converting 10 bits. So maximum actual data you are sending 8 bits only. Whether you want to send 40 bits or 50 bits, but it will split accordingly. So receiver will get to understand like I will get as a sequence number, then I will get as a header. So it will be the very clear idea to receiver will understand. So by using this boundaries, receiver will understand very easily. So in this layers, it will happen layer app. Now we'll see the data link layer. So already I told in the data link layer what happened. It will adding as a sequence number LCRC. Now assume as a you have a header data ECRC, ECRC header data ECRC. Once let us say I am sending as a 20 packets. Let us take one example. So let us see you are sending 20 packets means it will add as a sequence number. First packet sequence number, that sequence number protection purpose we are using LCRC, link level CRC. So let us you are sending 20 packets from transmitter to receiver. So what happen? Now you will give as a sequence number. Sequence number will be the 12 bits. LCRC will be the 16 bits. Header I already explained. Data it's a, I explained. Data it's a variable. ECRC means 32 bits. So sequence number 12 bits means 2 power 12 combinations. You can give the every identical number. So 12 bits mean 2 power 12 combination you will give. So 4 KB, 4 KB, 4 KB sequence you can able to send means 0000 like that, 000 000 this is a 12 bits, right? So this is a you are giving first packet. Then after 000 so up to how many bits you have a 2 power 2 12 bits, right? So 2 power 12 combination you can give. So how many packets you can able to send from the one transaction? 4 KB, 4000 4096 packets you will give as a sequence number. If you are sending more than 4096, again it starts from the zero, like that. So this is a one simple example. It's not be the same case for every time. So it will be the one simple example to what is the significant of mere significant of data link layer, sequence number and LCRC. So LCRC helpful for link level, any correction will be there, any voltages, any data will change from transmitter to receiver. So what happened by using data link layer, it will detect that error, it will send again. So how it will send again, we'll see. Let us, you are sending as a 20 packets. So transmitter will generate as a 20 transaction layer, it will generate as a 20 packets. Once the transaction layers generate 20 packets, it will give as a data link layer. Data link layer, what happened? It will add as a sequence number LCRC, sequence number LCRC. So this is data coming from the transaction layer. So it will give as a sequence number one by one. So this is a one specification. Let us assume scenario where in the link layer any error happen, may data may change something. So once whatever data it's from the transmitter side, what happen, you are sending the packets appending sequence number and LCRC. Once this packet received same or another side of data linker, what happen, it will check. Let us, I am sending as a 20 packets, so it will go as a 0 1 2 3 4 5 so on up to 19 it will go. So it's, you are sending in this manner, let us assume. So here it will check, now I got as a sequence number 0, okay, it's fine. You next I have to get as a 1, okay, fine. Next I have to get as a 2, 2 to some issue, some happen, assume as a 3 got a first, 2 got a second next time. So what happened, that sequence got lost. That is we call as a, this is we call as a ordering. So if you are sending same order, due to some issue, anything some issue happen in the link level, data is got changed. So from whatever data you send from the transmitter side, receiver got to like data is changed. So what happened, data link layer will tell as a error, I got an error, that packet I have to get again. Let us say 15th packet got as a error. So from transmitter to receiver, so receiver will tell to transmitter, I got a 15th number packet as a error. That it's giving as a acknowledgement, whatever if you are getting good packet, you will get as a acknowledgement. If you are not get a good packet, then also you will get as a acknowledgement. This is we called as a acknowledgement. No acknowledgement, it's not a correct acknowledgement. So ack means acknowledgement whatever data you are sending properly. If you get as a ack from the transmitter to receiver data link layer, that information you are sending, let us assume here in this this is a data linker, you have a 20 packets. So you have a receiver as a some 18th 15th packet you received, 16th packet gets corrupted. So 16th packet will send as a, I'm getting as a bad packet. That is we called as a knack. 16th packet got error means up to 15 received, right? Correct. Up to, so means it's 16th packet you got a error from the receiver to transmitter side, means you got a up to 15th you got a correct packet. So that 16th bit will send from again. This is we called as a retry. You sent data. Due to some issue it's happened, it's corrupted data. So data link layer will take care, will tell receiver will send to transmitter like, I got a knock with the sequence number as a 16. So what happened, again it will send from the 16, like that. From the, by using this knock, you will get a, whether you will receive as a good packet or not. So what happened, this DL will send again that packet to, from transmitter to receiver. This is we called as a retry mechanism. One more point we called as a data integrity. Data will take care in data integrity. This is concept we call as a data integrity. It's taking care of the data from the transmitter to receiver. So in the main concept here, what I want to explain here is, by using ACNAC protocol, we can able to detect the errors. We can able to tell to other end of the transaction data link layer whether it is received packet good or not. So what happen? Main concept will be the first one will be the sequence number. Next one with the LCRC. Then after retry. So these are the features we'll see in the data link layer. Let's one more point. We'll go next step is a specifications, more specification. Data link layer. I already explained. Data link layer is a gateway. It's kind of a gateway from the one transmitter to receiver in a middle. Each in the layer middle we have a gatekeeper. So whatever we need to take care of the these two layers from transaction layer as well as a file layer. So this we call as a gatekeeper. It will work as a gatekeeper. So one more is a data link layer. Make sure that each packet makes its across in the link. Whatever packets we are sending from the transmitter to receiver, it will check whether I am sending packet correct or not. If it is correct, it will send to transmitter receiver to transmitter as a if you are not received correct packet, you will get as a knock. So based on that information, the data link layer will proceed accordingly. So main concept will be the now we'll see the main two main things in the data link. I already explained. One will be the sequence number. Next will be the LCRC. What is the significance of LCRC? It will protect that packet through that link in the PCIe. So we'll see the one more point. From whatever data getting from the transaction layer, it will generate the uh, data link layer packet. That packet we called as a link packet. That packet we called as a link packet. Whatever packet we got from the data link layer we called as a link packet. So link packet in data link layer it will generate as a some other packets. It will be the internal of data link layer. So whatever data from the transaction layer, it will be the actual data. But before sending to packet, we got to know like information. Like let us take example. You have a one room, you have a another room. Let us assume in this room we have a 20 chairs. In this room, let us assume 7 chairs only. So let us I want to send the students from this room to that room. So what you will do? First, it will check how many chairs are available. Some exam is going on, you have to see the availability that let us assume seven benches are it's vacant. So what you will do, you will send us a seven members means seven packets. So we should know, right, before sending the data from transmitter to receiver, you should know how much space is there. Let us take one example. Once you let us assume you connected a hard disk in your laptop. Once you connected your laptop that hard disk, it will show the display like what is the total area of that hard disk, what is the available area, what is the available area, this much is the available area, this is a full of some files, what are the files is present in this area. So everything we got to know, like based on that space only you can able to write the data. If you have enough space, then only you can upload it. Let us take as a Google Drive. Let's take as a Google Drive. If you have enough space, then only you can upload the videos or photos. If you don't have a space, you cannot upload, right? Same scenario here. Whatever packets you are sending from the transmitter to receiver, you should know what is the receiver acceptance, what is the capability. So this is we called as a by using in data link layer. What happened? It will send as a some own packets that we called as a DLLPs, data link layer packets. By using this packet, we got to know like, what is the space available in the receiver side. What are the specifications it's available in the receiver. So by using data link layer packets, what happened? We got to know like this is a space I have. So based on that space, I can able to send the packet. So let us assume here I have a space. Assume as a I can able to accept only two packets. So this data link layer got to know like I have anyway I am getting 20 packets, but I have to send as of now two packets to only from the data link this link layer to this layer. So this is we called as a updating. updating that information from receiver to transmitter. This we called as a flow control. That flow that packets is updating, right? This updation we called as a updating. Credit means that that data, whatever data we call as a credit information. That is based on that information, you will get to like receiver side how many packets it's going to be select, how many bands it's going to be accept from the transmitter to receiver. So this is we call as a credit mechanism. Like how many credits are available. Let us, I have a 10 credits here. Let us assume 10 credits. So 10 credits, let us take as a size is a 1 TB. Assume 10 credits means 1 TB, let us assume. 1 TB means receiver will tell to transmitter, I have a 1 TB space. You can able to send the data up to 1 TB. This is we called as a credit mechanism. This updating, right, from receiver to transmitter, it updating this 1 TB space is available in the hard. This is a EP assume as a hard disk. So hard disk will tell to the laptop, I have this much space. This is we call as a updating the space. This we call as a up, updating of that information. That credit is updating. This is we call as a updating of credits. So we'll see in a next video. We'll understand more clear up what actually credits, how it will send data. This is we call by using DLLPs. We'll see the one example for that. You will understand very clearly. So data link layer packets. By using data link layer packet, what happen? We'll get to know the information of receiver end, how much data it's going to be accept. Th- So main things we are usually the data link layer packets, mainly data exchange. That data is exchanging, right? Whatever information received there in the from the receiver to have that information, it will send to from the transmitter side. So data exchanging happen. Error also detect, it will retry in the. So flow control mechanism, data link layer packets. What is the ACNAC? I already explained. What is the update flow controller? Update flow controller, simple example. Let us, you have a transmitter, you have a RC, you have a EP as well. If you have a 20 chairs, let us you have a 30 members, you have to send from transmitter to receiver. If you have 20 chairs, that 20 chairs will be updated to transmitter, receiver to transmitter. Like I have enough space only 20, even though you have it 30, but I can accept only 20 from EP side. Let us take it, this is connected with the hard disk. This is your laptop. This is your laptop. So hard disk will accept only 20 packets, but our laptop want to send 30 packets. So it will tell first, as of now I will accept 20 packets. So what happened, this is we called as a updating the information from receiver to transmitter. This we called as a update flow control. It will updating the information. Flow control, initialization, flow update flow control, it will update the credits of the that receiver end. This is we called as a update mechanism of the using that DLLPs. So in this data link layer, main features will be the sequence number and LCRC. Then data link layer will generate its own packet. Those packets will help to get the information from receiver to transmitter using information like it's kind of ACNAC, whether it is update flow controller or flow controller. Any initialization packets will be there. Any retry packets will be there. So all the information coming from the receiver to transmitter using DLLPs. So the in data link layer, if you are sending actual data from transmitter to receiver, you should have enough space, then only it will send. But DLLPs will be the not a actual packets, it will be the generated from the data link layer from the transmitter, received from the data link layer of the receiver end. So it will be the, there is no point to stop these packets. The link won't stop these packets. If you are sending actual data, if you have enough space, then only you will can able to send. But these DLLPs will be updated in concurrently in parallel. It will update from the receiver to transmitter side and transmitter to receiver side, both side. So in this way, data link layer mainly helpful. So one example here I will leave the, let us take, I want to send let us will discuss the all the information in next video. As of now what we discuss, Uh, in PCIe transaction layer, different types of packets generation. Whatever packets coming from the transaction layer, we data link layer will add, it will append some sequence number and LCRC. That packet will send to physical layer to receiver side. So this is a one concept. One more will be the data link layer will generate its own packets that we call as a DLLPs. That by using this DLLPs, what happened? You can able to identify the some features. It's kind of ACNAC related. I already explained. Some flow controller related, some power management related. Let's you want to put as a low power mode that link, so you will using that DLLPs you can put as a low power mode. So these are the features we will see in the using the DLLPs. One more is a DLLPs will be the intermediate. It will be the generated from this data link layer. It will consume from the this data link layer only. So it won't go this packets to from the transmittering of transmitter side and receiver side. So by using this DLLPs, what happen? We will get the more information from the receiver end, what actually the related specification, what is the available space, what are the information ACNAC related. So this is the information about the data link layer of the basics. We'll see continuously in the data link layer with related specifications with suitable examples. So in this video I'm going to stop here as of now. If you have any question, please let me know. Thank you.